Right, guys, could you comment your name so I can do the register? At the moment, I've got Lucas. So if you guys could type your name, that'd be great. Okay, who's here? All right, Emily, Lucas, Eliza. New mic? No, I'm just chatting through the computer mic. Is it better or worse? I just thought this thing was quite cheap and nasty, whereas my computer's quite good, so the mic might be better. Plus, it's nice not having to have it on my head. Cool. I'll just use this instead then. Right. Oliver. Yep. I think that's all of you. 1, 2, 3, 4, 5, 6. Oh, and yes, Finn was here this morning. Harry was here this morning. Is Sally here? I know sometimes Sally can't comment, so Emily, is Sally here? You normally know. Cool. All right. So today we're going to be looking at vectors. Hopefully, we'll completely get through them, and that leaves us with 2 more topics for the rest of the week. So I'm just quickly going to summarize vectors, and then we're going to jump into some difficult style past paper vectors questions. Right. So 3 key aspects of vectors are direction, sketching them, and parallel lines. These are the 3 aspects, and if you get these 3, okay, cool. Thanks, Emily. These are the 3 aspects. If you can get these kind of sorted, you should find the whole topic quite easy. These are the 3 bits the 3 hurdles to being good at vectors. So we're going to try and get these sorted today. Okay, with sketching and direction, so we'll just kind of jump into it. All right, if I have 2 vectors, OA, both position vectors, and OB, and I want to find the vector between them, I could sketch these 2 on a graph. Now, I'm sketching 3-dimensional vectors in 2D, so it really doesn't matter where I put the points. Remember when we did that 3D lecture, and any way you kind of rotate it, as long as the arrows are pointing in the right directions, you can't really draw vectors wrong. So I always space mine out like this. I always put 1 here and 1 here. Reason being, they're quite far apart. They're also far apart from the origin, so you can draw lines and they would get all muddled up. So I just try and spread them out so every line has its own kind of angle. So there's OA, there's OB. So we're going from the origin to A, from the origin to B. If I wanted to try and find AB, that has to be in the direction from A to B. If I want to try and find that, we can use the triangle law. So triangle law says you can go backwards A, so minus OA, and forwards B, so OB minus OA. So that's like saying this route here is the same as going backwards this way, forwards this way. So minus OA plus OB. And you can always use a pen to see which direction things are positive. Draw arrows to keep a pen, make it positive. Right, so we're going to work out AB quickly. So we're going to do 5, 1, minus 5, 1, 4, take away 2, minus 1, 3. So we're going to get minus 7, 1 minus minus 1 is 2, and 4 minus 3 is 1. So minus 7, 2, 1. Right, if I introduced another point, if I put point C in there, we could say, I don't know, C divides AB, in the ratio 2:1, and we could use that to find out where C is. So if I make some space here, so because C is on AB, I can say AC is part of AB. It's parallel. I've used lambda because they're parallel. It's a fraction of AB, so we can use lambda as a placeholder. I could say mu as well. So if we wanted to get from the origin to C, we could go from the origin to A, then plus a bit of AB. So instead of the whole AB, we're just doing this little bit of AB, and that bit is a fraction of AB, which fraction is given by lambda. So yeah, we can work it out like that. So I'm going to get rid of OB here because we don't actually need this for this calculation. So OB is gone. If I want to find OC, we're going to go OA plus AC. So I always like to write out my vectors as kind of basic as possible and then layer them up each line. So OC is OA plus AC. OC is OA plus lambda AB. We actually know what lambda is because C divides AB in the ratio 2:1. So A to C is 2/3 of A to B. So we can say OC is OA plus 2/3 AB. So OC is OA, 2 minus 1, 3, plus 2/3 minus 7, 2, 1. It's going to be horrible fractions for this one. So if we work it out, we're going to get, calculator ready, 2 take 14, so that's going to be 12. No, it's not. It's going to be nothing like that because of the 3. Minus 7 times 2 over 3 is minus 14 over 3 plus 2 minus 8 over 3. The next component is going to be minus 1 plus 4 over 3, which is 1/3. And the last one is going to be 2/3 plus 3, which is 11 over 3. There we go. So that is OC. So trick to it, if, I didn't realise I was in the way then. If they're parallel, use lambda or mu. If they're on the same line, use lambda or mu. Draw your arrows carefully and diagrams. Spread out everything. As long as the arrows are pointing to the right letters, they shouldn't be too hard. Cool. Size of a vector, modulus. You're going to square it and square root it. And a unit vector is a vector divided by its own size. So if I wanted to find the unit vector, so if A is 2 minus 1, 3, if I wanted to find the unit vector A, oops, let's get rid of all this now. If I want to find unit vector A, which we notate with A, put a hat on it, we need to force A to have a size of 1. So we're going to do A divided by the size of A. So that's A divided by the size. If you find the size of A, that's going to be 2 squared plus 1 squared plus 3 squared, which is root 14. So unit vector A is 1 over root 14, 2 minus 1, 3, like that. Cool. Right, let's try some questions then. So first one, here's a triangle. Wait, it's not. Scroll down a bit. Cool. I'll give you guys, how many marks is it? It's 6. I'll give you guys 8 minutes to do this one because it is quite tricky. It's the first one we're doing, so to get you kind of into it. So could you guys do this? Please comment your answers when you're done. So 8 minutes there. Or if you need any help, comment. So timer starts now. Cool. All right, let's do it. Right. So first one, find C to. Okay. Right. Key to this one is the sketch. So, O to A equals A. OC is 2 lots of OA. So OC, C must be up here. If it's 2 lots of OA, it must be A and then A again. M is the midpoint, so M is there. The line through C and M cuts OB at point N. So there's a point there as well. So that's what your sketch should look like. So find CM. So C to M, which is this bit here. We can go C back to A and then A to M. So we're going to go CA plus AM. CA is minus A. Then AM is going to be half of AB. So I should have done that better there. CA is CA. Cool. So we know CA is minus A plus half AB, where A to B is going to be B minus A. If we simplify that, we get CM is minus 3 over 2A plus half B, like Lucas said. Nice. Alright, I'm going to write CM at the top just because I think we need it later. So CM is there. Okay, part B, find O to N. So O to N, there's 2 ways of doing it. You can either go straight there from O just horizontally. We don't want that, we want that later. Or we can go O to C, C to N. So that's how we're going to do it. We're going to say ON is OC plus lambda CM. Because we know CM, we just worked it out. Cn is on the same line, so we're going to use lambda. This time lambda, though, is going to be a top-heavy fraction, so because it's C to N is further than C to M. Okay, so we're going to go ON equals OC, where OC is 2A, plus lambda, what we got already, 3 over 2A, plus half B. We're then going to expand all this, so we get ON equals 2A minus 3 over 2 lambda A plus half lambda B. Then if we factorize the A's out, we get to what they wanted us to get to in the show there. So that's that bit done. Last part, hence proves that ON to OB is in the ratio 2 to 1. So we actually want to find out what the unknown constants are. So we're going to set our equation equal to another equation, ON equals mu OB, because obviously they're on the same line there. Set those equal. If we can find mu, that will give us the fraction that O to N is out of O to B. So mu OB equals 2 minus 3 over 2 lambda. Oops. Plus half lambda B. Interestingly, there's no A term in the second equation. Reason why is completely horizontal, you don't go up at all. So if we set our A term equal to 0, 2 minus 3 over 2 lambda equals 0. That's looking at the A parts. We can look at the B parts as well, and we get mu is half lambda. If we work it out, lambda turns out as being 4/3. If we half that, we get mu is 2/3. 2/3 shows this in the ratio 2 to 1, because it's 2 out of 2 our length of 3. Cool. Right, that was pretty quick, but hopefully that made sense. Any questions about that, guys? I'll move on to the next slide, but if you do have any questions, ask and we'll go back. Okay, this one's only worth 5 marks, but everybody struggles with this one, especially part 1. So if you get stuck on part 1, do part 2 first and then go back to part 1. The key to part 1 is a sketch, and the 2 parts are completely unrelated. So maybe try part 2 first, do that, will be okay, and then have a think about part 1. Sketch is the key bit here. I'm going to give you guys 8 minutes, even though it's worth 5 marks, because I think it requires a bit of time to get your head around and a bit of time to sketch.
Discover great music at kexp.org.
Right. Yeah, why are they parallel though? That's the hard part. So if I do part A first, the trick to A is a sketch. So if I draw some axes, there you go. Right, so if we've got two vectors A and B, here's A, here's B. Let's say that A has a magnitude of 5. Let's say B has a magnitude of 10. If I draw A plus B on here based on my sketch, A plus B looks like this. How can we work out A plus B's length? So A plus B. Because obviously with vectors we go up A, we go across B. That is A plus B. So if it was right angled, we could use Pythagoras. We get 5 squared plus 10 squared. Yeah. If it's not right angled, we could do cosine rule. Work it out that way. We'd need an angle, but we could do it. In any case, though, any triangle that we make will never have A plus B size equals A plus B. A plus B will never equal, in this case, 15. The only time A plus B will equal 15 is if B is parallel to A. And then A plus B would be the whole of that line, 15. So the only time when that's true is when they're parallel. They are parallel. Okay, CF is a hard one mark. I think that's why it's one mark, is that they imagine not many people would get it. Part B, we got a different question. Two different vectors. So if we draw some axes again, M, N. We've been told the size of M take N. So if I draw M take N on here, M take away N, M take N, it's going to be, we could draw it as this line here. So that way there. So you can imagine M take N is minus N plus M together. So we know this length here is 6. We know M has a length of 3. We're told the angle between M and N is 30, so we know this angle here is 30. And we're trying to find the angle between M and M take N. So we want to try and find this angle here. Let's call it X. So the trick to this is using the sine rule to find this angle, and then use that angle to find X. So we're going to do sine rule to start with. So we're going to say, if I call this one Y, sine Y over 3 equals sine 30 over 6. Get times the other side by 3 to get sine Y is half sine 30. Sine 30 is a half as well, so sine Y is a quarter. Arc sine of a quarter to find Y. And we get Y is 14.48 degrees. So that's this angle here. We want to try and find X, so if I do 180, take that, take away 30, we get 135.5 to one decimal place. So X, 135.5 degrees. There we go. Right, let's try the next one. So next up, this one should be pretty straightforward. I'm only going to give you 4 minutes to do this one. So give it a go. Cool. Right. So point A there, point B there. AB is going to be B take A. Okay, sketch it if you want. AB. So minus A plus B. And we're going to get 5, 10 there. Find modulus of AB, 5 squared plus 10 squared, square rooted, is root 125, which is 5 root 25. So nice and easy. Okay, let's try and find one bit harder. Okay, if you guys could try this one, what's it worth? 5. Give you 6 minutes, give you a chance to write it down. So 6 minutes done. Cool. All right, so AB equals BD, so we need to find D. So if you find AB first, AB is B minus A. 4 minus 2, 3. Take A, 2, 3 minus 4. So 2 minus 5, 7. That's AB. Now that equals BD, and BD will be D take B. So 2 minus 5, 7 equals D. Take B, and B is 4 minus 2, 3. So if we add B onto the other side, we can find D. So D is going to equal 6 minus 7 and 10. Cool. All right, last bit then. Given AC is 4, so we need to use A and we need to use C, and then we're going to set them equal. Sorry, we're going to find AC and then we're going to set the size of it equal to 4. So AC is going to be C take A. So A, 5 minus 2, take away 2, 3 minus 4, gives me A take 2, 2, 2. We know the modulus of that is 4. So A minus 2 squared plus 2 squared plus 2 squared equals 4 when it's square rooted. So A take 2 all squared plus 4 is 16. So square both sides. Take away the 8, so we get A take 2 squared equals 8. Square root both sides, and we get A take 2 equals 2 root 2, plus or minus. We're told that A is going to be less than 0, so therefore A is going to be 2 take 2 root 2. Cool. Right, how many more have we got? This horrible question. Okay, and then... Cool, we're only going to do one more, so we might finish a bit early today because I've been racing through it. Okay, I just lost the page there though. Better. Alright, I'm going to give you a while for this because I really would like you guys to try and do this one. So I'm going to say 12 minutes for this. Sketch it, add vectors to your sketches, work out 2 roots to the intersect, call the intersect x. Message if you need any help, but I would like you guys to give that a go. If you get stuck or if you want me to check it, send your workings to the Google, not to the Google Classroom. Send your workings to the Microsoft Teams. Okay, 12 minutes starts now. Yeah, nice. Well done, Oliver. Let's go through this and then we'll call it a day for today. So we're trying to show that this line and this line intersect, but also that they bisect. So I'm going to call X my intersection there. And so I'm going to come up with two different routes to get to X, one using the red line, one using the blue line. So to do it via the red line, nice and easy, OX equals lambda OF. Pretty straightforward. My other route, OX, is going to be O to A plus mu AG. So that's going this way, and then this route is going straight there. Okay, so we're going to kind of break this down and do it again in steps of A, B, and C. So O to F is going to be A plus B plus C. So we get OX is lambda A plus B plus C. OX here is going to be A plus mu AG. AG is going to be minus A plus B plus C. So B plus C take A. Right, now we can set those two things equal to each other because they're two routes from one place to the same place. So we're going to say lambda A plus B plus C equals A plus mu B plus C take A. Then we're going to solve the A bits, the B bits, and the C bits. So the A bits first, lambda equals 1 minus mu. The B bits give us lambda equals mu, and the C bits also give us lambda equals mu. So we're going to solve those together. So I'm going to put lambda equals mu into my first one, the A one. So we get mu is 1 take mu, so 2 mu equals 1. Therefore, mu equals half. Therefore, lambda also equals a half. Because they equal a half, it bisects. And because we could solve it, they both go to the same place. So that proves that they bisect each other. Cool, right, somehow that was 25 minutes faster than when I taught this earlier today and yesterday. Weird. So yeah, tomorrow we're going to do, oh yeah, that's fine. So I'll leave this one up now. You can start it now. We're going to go through this one as a starter tomorrow. So it's a 10-mark question. You can start it now for 10 minutes. We're just going to jump straight into it tomorrow. So could you guys have a look at this before tomorrow? So you can start it now. I'll stay here so you can ask me if you need any hints or any help with it. Yeah, and that'll be it for today. So if there's any questions, please ask. I'm still going to be sat right here, but I'll put the timer on and give you guys 10 minutes to start working through this one. Make sure you sketch it. So 10 minutes starting Cool. Yeah, thanks, good guys. So we'll go through this tomorrow. I'll see you then, guys. Thanks for tuning in, and see you then. Bye.